Now what we have to do is like, this dipole will produce field here. In what direction will be towards right. Then calculate the field strength. So let this distance be equal to so can we assume this distance to be L? So at this location, what is the position of this point charge will be L x minus L. So the field strength here will be more than this. So they'll experience a force. The difference of that force is what? Force of interaction. You can do by that method. Let me come by the other alternative. Try that one. Find out the field strength due to this dipole at the position of this positive point charge and also this negative point charge. Let the charge be plus Q minus Q. Then calculate. Let me go for the another method. Shall we calculate interaction potential? So I'll assume that the dipole 2 is present in the field of dipole 1. So in what direction this first dipole will produce here? It will produce the field in this direction. What is the interaction potential between them? U is equal to minus P1 dot minus P2 dot E1. P2. I changed it here. So the interaction potential G, okay, it will be like this. So there's a negative charge, there's a positive charge, no? We'll put in this way, you know. So now this will become U is equal to, what is the angle between them? 180 degrees. So P2 E1 cos 180. So this will become P2 E1. Cos of 180 will be minus 1. So this will get the interaction potential energy. Now what is E1? E1 should be equal to 2P1 4 pi epsilon naught x cube. So this will become P1 P2 by 2 pi epsilon naught x cube. I know potential G. Let me differentiate this. Du by dx. This should be equal to minus 3. This 2, let it be there. Huh? So minus 3 2P1 P2 by 4 pi epsilon naught x to the power of 4. Will I agree this? X to the power of minus 3, the derivative of this u, what happened? Du by dx will get it. We know the force F should be equal to minus du by dx. So minus du by dx will become 6 P1 P2 4 pi epsilon naught x to the power of 4. I got directly F positive. What do you mean by that? If F positive, it will be repulsive. If F negative, it will be attractive. So what these dipoles are trying to do now, that they'll exert a repulsive force on each other. This is applicable for only conservative fields. This equation is applicable only for conservative fields. I am making a very strict condition. Now, similarly, if the dipoles are, look at how the electric dipole moment, they are in same direction. No? If the electric dipole moments are, so like they are in opposite direction. If the electric dipole moments are in same direction, what conditions will arise? Slightly, I'll change the diagram. Anything now? Yes. What about the force of interaction in this case? Will be attractive, no? F will be negative. In fact, you check it, calculate, no? F will come negative. So again, the force of interaction will be F. This will be F. So how much F is equal to 6 P1 P2 4 pi epsilon naught x to the power of 4. solve it mathematically, you'll end up with negative sign. So it's attractive. If you end up with positive sign, it'll be repulsive. Then how do this force of interaction proportional to 1 by x to the power 4? Very important for exams, do remember. The force of interaction between dipoles is proportional to 1 by x to the power 4. I think this will be better, easier method where I'm bringing some energy idea. Or else, what is other alternative? The other alternative is like, you know, the field strength here, how much E1. Then, so for a small distance dx, so instead of this L, no, you write it as dx. Then, if the distance slightly decreases, then field strength here will increase. Then similarly here, the field strength, what happens, should decrease, here increase. So these two will experience a different force. The difference of that two forces is what we got this particular thing. So I think in books they have shown that method also. If you are interested, try to think on that. I'm just taking help of the energy method. Any doubts, you can clarify.